Welcome to our lecture on UIKit. In this lecture, you're going to learn about the most important framework for building iOS apps. And by learning about the UIKit framework, you will also understand what the fundamental building blocks for iOS apps are. If you have never worked with a framework before, this lecture will cover a lot of new topics. However, don't be afraid. All of our tutorials will incorporate these topics and discuss them in more detail. First, let's get started with discussing what UIKit is. UIKit is the core framework that helps us build iOS apps, and it does that in two different ways. Firstly, it provides default components. And if you ever wondered why iOS apps have a similar look and feel across many different vendors, that is because of these default components. Apple provides buttons, image views, and different components that we can reuse in different apps that make our apps behave and look similar, which is really great for the user. Additionally, UIKit also provides a skeleton for how we write our codes for our apps. So instead of reinventing the wheel every time we start a new app from scratch and we have to wonder how to write code for it, UIKit actually provides a framework, and it discusses certain rules of how we should write our code. The main components of the UIKit framework are views, view controllers, and scenes, all of which we will discuss in detail throughout this lecture. The typical iOS app consists of multiple scenes. In this example here, we have an app with 3 scenes in total. The first one is a login scene. Then we have the main scene that has the content of your application. And additionally, we have a settings scene that allows the user to change certain preferences. Additionally to these scenes, most of our apps also consist of transitions between scenes. In this example app, we can transition from login to the main screen, and we can transition between main and settings. Scenes and transitions between scenes make up the structure of our applications. So the first thing you do when you want to build an app for iOS is think about these different scenes and how they are connected to each other through transitions. Next, let's take a look at scenes in more detail. Here is an example of a very simple scene. It contains a view controller and multiple views. That is the typical structure of a scene. It typically consists of one view controller and multiple views. Views are responsible for displaying information, and they can capture user input. Some examples here include text fields that allow the user to enter text, buttons that allow the user to tap and interact with our views, and image views that allow us to render images on the screen. View controllers are containers for these views, and we'll discuss them in more detail now. View controllers are one of the most important components in our iOS apps. Let's take a look at them in more detail. This is an example of one view controller. It is from the calendar app that is installed by default on all iOS devices. In most cases, for most of your applications, one screen will be represented by one view controller. There are some exceptions, but in most cases, every scene will only have one view controller. Each of these view controllers has exactly one root view. And then we add different subviews to the root view of that view controller. So the calendar app that you can see here on the right basically consists of one view controller, one root view, and many subviews that each represent different UI elements on the screen. A view controller itself has no visual representation. You can always only see the views that are added to that view controller. So what is the responsibility of view controllers? How do they fit into our applications? The main responsibility for view controllers is to manage views. View controllers get informed about different system events. For example, when views appear on screen, when views disappear, or even when a device rotates. The view controller uses that information to make changes to its views. We will discuss the responsibilities of view controllers in detail later on throughout this presentation. First, let's get an overview of what views are in UIKit. Essentially, anything that can be displayed on a screen is a view. Views have a couple of important properties. These include the size, a position, its appearance, and also that they can consume user input. We have already seen different views, for example, text fields that allow the user to input text, and buttons that allow the user to tap and allow our application to respond to these taps. All of these functionalities are provided by different view subclasses that UIKit provides for us. These include image view, text fields, buttons, labels, and so on. As you start working with UIKit, you will understand which view subclasses are available to you and how to use them throughout your app. Views can be combined into a view hierarchy. Here on the right-hand side, you can see a simple view hierarchy. It has a label on the top, a text field below, then it has a gray view, and on that view we have two subviews. These are two buttons, one placed to the left of the center and one placed to the right of the center. This is how you typically build a view hierarchy. You add different views as subviews to their parent views. Every view can have other views as its subviews. All views are positioned relative to their parents. In this example, the buttons are positioned relative to the gray rectangle that you can see. If we move that gray rectangle, which is also a view, then the buttons, which are the subviews of that view, will move with it. That is the basics of view hierarchies, and we'll cover a lot more in our auto layout lectures and tutorials. One important question that we haven't covered so far is how views and view controllers work together. What are their respective responsibilities? The answer lies in the model view controller paradigm that is used throughout the entire UIKit framework. And that has some implications of how different parts of our app should work together. Firstly, a view should only display content. Typically, views should have very little code, and all of the code that is contained in there should just be responsible for showing information on a screen. More complex tasks are handled by the controllers. The view controller is responsible for processing user input, modifying and updating the view accordingly, and also for communicating with the model part of our application. Now, we've talked about views in pretty much detail. We'll talk about controllers and models over the next couple of slides. But why do we have this division in the first place? There are a couple of good reasons that software developers have found to follow this MVC pattern, as we call it. The first one is we can reuse views in different contexts. If your views don't have a lot of application-specific code, then it's very easy to take them and reuse them in different projects. And that allows us to be much more efficient when building apps. Furthermore, when we follow the MVC paradigm, we're bringing consistency to our codebase. If developers that are familiar with MVC take a look at our codebase and want to modify individual features, they typically know where to look. If a developer wants to change a view, they know that they have to look in our view files. If they want to change something about the core behavior of the app, they know that they have to look at our model files. This is very helpful when working in teams or over longer time spans on large projects. Additionally, we bring separation of concerns to our project. That means we have different parts of our application that have clear responsibilities. That makes it easier to keep these parts small and easily readable, and that means in future we can additionally add features. In bad iOS apps, we typically have all code within view controllers. In a good application, we try to separate out behavior into different views and models to keep the code in every single file short, concise, and separated by concern. All of this is very helpful as your projects grow. Now let's take a look at an example of a view in UIKit. Here we can see a UI user account view as an example. This account view shall take a user and display basic information about them. It shows their name, their job role, their email address, and their profile picture. Additionally, it provides two buttons to interact with that view. Firstly, it allows users to contact other users, and secondly, it allows users to delete this user from their address book. The way we would typically structure such a view in our iOS app is creating a separate view subclass, in this case, UI user account view, that takes a specific type of object that it then represents. In this example, the account view takes a user object. That user object contains all information that we want to display on screen. The view takes this object, extracts the relevant information, and represents it on the screen. This is the typical responsibility of a view. It receives an object or a set of objects and then displays them. The view can also capture user input. In this example here, it does that by providing two different buttons. However, typically, the view should not perform any complex code. Instead, that work should be handed off to the view controller. And we'll see more about that on the next slide. Lastly, it is important to mention that custom views, like the user account view, will use other standard views as their subviews to represent information. In this example here, the account view uses an image view, 2 buttons, and 3 labels to actually compose the user interface that represents the user account. Now let's take a look at how controllers and views play together. This example doesn't only include the user account view, but also the user account view controller that belongs to it. This is a typical setup in most iOS applications. A view belongs to a view controller, and a view controller manages certain aspects of the view. In this example here, the view controller receives a message from the iOS operating system. That is the view will appear message. This message is always sent when a view will appear on the screen because a user has navigated to a certain part of an app. We will later talk about the view lifecycle and these messages in more detail. This view controller here decides to download the user information as soon as the view appears on screen. This is a very typical pattern. We wait until a view becomes visible, then we fetch some information. We do this in the download user data method of the view controller. As soon as the user data has been downloaded successfully, we create a user object, and then we hand that user object to the view of the user account view controller. The user account view then takes that user object and represents it on the screen. At this point in time, the view is set up and the view controller is waiting for new messages to occur. Second type of message that a view controller can receive is one of the button taps. As mentioned earlier, the view should not handle button taps itself. It shouldn't perform any complex code when buttons are tapped, but ideally it should inform the view controller, and the view controller takes the complicated part of actually performing code. So in this example here, when the contact button is tapped by a user, the user account view will inform the user account view controller that this event occurred. The view controller will then, in this case, present an email view controller that allows a user to email another user. So the actual code, the actual response to the button tap, lives inside of the view controller. This is how view controller and view typically play together. The view controller fetches the information displayed in the view, then provides that object to the view displays the object, and the view captures user input and informs the view controller when user input occurs. Now let's extend this example by including the model of an application. Let's say a user wants to be able to delete other users from the address book. How would we add this feature? First of all, we need a connection from the delete button to the view controller, so that the view controller is informed when the user hit the delete button. This is what the extended example looks like. When a user taps the delete button, we call a second method in the view controller, similar to the contact user pressed method. In this case, it is called delete button pressed. Now we perform a remove user method. This is something that should not happen inside of the view controller. Removing information in our app is typically something that belongs into the model layer. In this app, for example, we have a part that is responsible for handling users and storing all the users that live in our application. This class is called user accounts. We call remove user by ID on that user accounts class to actually remove the user from the database. After this is complete, the view controller updates the UI by removing this user account view. This is the extended communication pattern between views, controllers, and model. The view informs the controller that a user input occurred. The view controller decides which part of the model is responsible for performing the actual action, in this case, deleting the user. And after the action is complete, the view controller updates the UI accordingly. Let's summarize what we discussed over the last couple of slides before we move on to some more aspects of UIKit programming. Firstly, views and view controllers are the building blocks of iOS apps. We have seen that each screen in our iOS app is represented by one view controller and multiple views. View controllers themselves don't have an appearance, but they have a root view. By adding multiple subviews to that root view, we create the appearance that we want to show in a view. In one example we showed, we had a user account view that consisted of multiple subviews, such as an image view, 2 buttons, and 3 labels. These views that have subviews form a view hierarchy. We also learned that views should not contain application logic. Views should delegate that to view controllers. Views inform the view controller about certain events, but a view controller actually performs the application logic, or talks to the model and lets the model perform the application logic, and then updates the view as soon as that application logic is complete. One example that covered the communication between the view controller, the view, and the model of our application throughout the last slides was the deletion of a user account. The user tapped the delete button in the view, that was communicated to the view controller, and the view controller finally told the model to actually delete the user account. This part summarizes basically the most important information about views and view controllers. But we covered some side aspects which I want to cover in more detail now. The first is the view lifecycle. I've already mentioned that this exists, but we haven't discussed it in detail. In UIKit, views live through different parts of the view lifecycle. First, views get created, then at some point in time they appear on screen, then they disappear, and finally they are destroyed. For each of these lifecycle events, the view controller that owns the view receives certain method calls. We will only discuss the most important ones now. The first method that is called on a view controller that is very important is the viewDidLoad method. This method is called as soon as the view is loaded for the very first time. Typically, we can initialize view properties in here. That can be any property that needs to be set in code and cannot be set up in Storyboard, which is the visual editor for views. The second important set of lifecycle methods are the viewWillAppear and viewDidAppear methods. These get called as soon as a view appears on screen. This happens at any point in time where the user navigates to a certain view through different means. Both methods are called at slightly different points in time. ViewWillAppear is called before the view is presented, and viewDidAppear is called as soon as the view is finally completely presented. If you don't present a view with an animation, both are basically called at the same time. If you present a view with animation, viewWillAppear would be called at the beginning of the animation, whereas viewDidAppear will be called when the animation is completed. You will really only need to differ between these two different types of methods if you use animations to present views. Either of these two methods is a good place to load initial data for your view. As we have seen in the example earlier, as the user account view controller got displayed, we downloaded user information and displayed it on the screen. This is something you typically will do in viewWillAppear or viewDidAppear. These two appearance methods also have a counterpart. ViewWillDisappear and viewDidDisappear. They work in the same manner. If we use animations, they are called at slightly different times. If we don't use animations, they are called at the same time. These two methods are a good place to clean up resources that you no longer need if your view is not displayed on the screen, and also, for example, to perform save on edited data. In the example of our LIFECYCLE Notes app, whenever the view disappears where the user can edit a note, we will save the information to disk. This is a good task that you can perform within the viewWillDisappear or viewDidDisappear method. The view lifecycle has some more details that you can learn about, and you will learn about it throughout our tutorials, and Apple also provides some amazing documentation on them. Next, let's look into scene transitions. We already mentioned that scene transitions are an important aspect to move between different parts of our apps. These scene transitions are called segues in UIKit. And segues can be created in Storyboard. We will discuss Storyboard in a separate lecture and a screencast, because it's a really impressive and powerful tool. What you basically can do is define different transitions between different scenes in our app. And additionally, we can define when these transitions are triggered. They can either be triggered by actions, such as a user tapping a button or selecting a certain part of a screen. But we can also trigger them manually in code, and that sometimes will be necessary. Additionally, view controllers can perform code when segues occur. As we'll see throughout the tutorials, that allows us to hand information around as soon as segues happen in our app. We will discuss scene transitions in the tutorials in detail. The last aspect of this presentation are container view controllers. They are another essential building block of iOS apps. We will be working with two different container view controllers throughout our tutorials. Container view controllers have certain responsibilities for transitioning between scenes. Typically, container view controllers contain all scenes of our app, and all transitions between these different scenes happens within that container view controller. Most apps have at least, but mostly also only one container view controller. That container view controller contains all scenes of the app. One very typical example on iOS is the navigation view controller, as seen here in the Mail app that Apple provides. The UI navigation view controller is a container view controller that provides us with a stack of different scenes. You know it as mentioned from the Mail app or also from the Messages app on iOS. The navigation concept behind this controller is a user can tap on any of the entries, and that will push a detail view controller for that entry onto the stack. For example, when a user selects a mail from the list, the user will see a detailed information about the email with the content of the email, sender, recipient, and so on. That view controller will also provide a back button to pop back to the list of emails. This is the typical navigation scheme for the UI navigation view controller: push and pop of different view controllers. We will be using this container view controller in the LIFECYCLE Notes app. The second type of container view controller that iOS provides is the tab bar controller, and that is one we're going to be using in the Makestagram app. The UI tab bar controller allows a user to switch between different scenes by selecting a tab bar entry in the tab bar at the bottom of the screen. As you can see, these two very common navigation patterns for all iOS apps are provided by container view controllers that contain all different scenes for our apps. You will work a lot with these container view controllers throughout our tutorials and in your original apps. This was a lot of information, so let's summarize what we've learned so far. First, we discussed that apps consist of multiple scenes. We saw an example of a login scene, a main scene, and a settings scene. And we also discussed that when building your app and designing your app, you should first think about which scenes are contained and how you want to arrange them, and the transitions between them. These multiple scenes and their transitions are placed within a container view controller. We have seen two popular examples, the navigation controller and the tab bar controller, and we will be using both of them throughout our tutorials. We also learned that we can transition between scenes, and that these transitions are called segues. We also looked into detail how scenes are built up, and know that they consist typically of one view controller and multiple views. Understanding what view controllers, views, container view controllers, segues, and a view lifecycle is will help you a lot when going through our tutorials. You will learn more details about the UIKit framework and how to program with it efficiently. As I mentioned, if this is the first framework you're working with, then there's a lot to learn and a lot of documentation to read. Our tutorials will guide you, but Apple also provides some available resources that are very valuable if you want to dive into the details of the topics that we discussed. These are the View Controller Programming Guide and the View Programming Guide. When working with complex frameworks such as UIKit, it can often pay off to read these additional resources up front and spend more time learning before actually diving into using them. We will leave the choice to you.